welcome everybody. We are live with a very special edition of Momentum today, which is the first ever public demo, and it's very much a demo. All of this could go terribly wrong, of Supernova. So we're extremely excited to share this with you. I'm here with my trusted co-host, Mihai. How are you feeling? We cannot hear you. That's the first thing we'll need to fix. The demo before the demo is already a risky experiment, but maybe I have. Oh,
I can hear you.
Look at this.
Yeah.
You're the wrong Mihai. Here he is.
Here I am.
Mihai.
Can you hear me?
Yes, we can hear you. How are you feeling?
GM, I'm fine. I'm so happy to be here 1 week earlier than what we planned, but it's a very important milestone, and it's very nice to share it with everyone in the community and friends and people. And
yes, let's set the stage a little bit. Supernova is the biggest ever upgrade for the network. This is basically a complete re-architecturing of the network. We'll talk about a little bit on the technical details in just a minute. But this is a demo. You'll get to see a behind the scenes look, basically what the team has been wrestling with, and see how difficult this is, and then also how awesome it actually is when things come together and when they work. So I think it's time that we bring some more guests on stage. Let me welcome, if I can see them, Adrian, or are you just, yeah, exactly. Adrian is right there. How are you, Adrian?
Hi. Yeah, I'm very good. Good to be again in the podcast, in the call.
And then I also have another special guest. Welcome, Lucian. How are you doing? Yeah, I made the joke earlier today that Adrian can be heard praying to the demo gods today. So this is definitely a big one. Just a few minutes ago, everything worked. So we'll see how it goes. I also am missing one special guest here. Do you see your brother near you, Lucian? I don't see him in my videos. Okay. Oh, Lucian, 1 second. I need to. Can you unmute yourself? I see a mute button. I see. Awesome. That's so odd that I hear your audio and the audience can't. But here, Benjamin, how are you? We have the next.
Hello. It's really great to be here, and I've begun the demo in the best way possible with the kind of fail on the internet. So since it's the demo, I'm just warming up to all the different ways that this can fail. I'm on the road, but we're pushing this, and it's, I think, really great to get the people a bit more on board in how it feels in the engine room. Last minute tweaks, some updates, everything seems to work, then everything seems to fail. Internet goes down, and boom, we are doing the Supernova pulse check. Great to be here.
Amazing. Lucian, let's just test your sound again. And chat, please let me know if you can hear him. Lucian, say something.
Yeah.
Okay, good. Let's see if that works going forward. I see the mute button over your thing. I don't think I can do anything about it. I can hear you, but okay. Let's see. Still no sound. I hear from the people. Okay, maybe we need to relog you in, Lucian, and you'll join us in a second, and then we'll get there. But it's always good, like Benjamin said, we'll start this in the most chaotic internet fail way possible, so then the rest of the demo can go well. I want to go, like I said, set a little bit the context for the stream and for everybody watching on like what sort of technology actually Supernova is and all the work that went into it. So kicking it to you, Adrian, to walk us a little bit through what Supernova actually is, what it means, the challenges you encountered while building it, the rethinking of the architecture. Give us a little bit, take us on that journey that you've been on for the past however long, over a year, and give us some insights on what you learned and what Supernova is.
Yeah, so I think we started
2 years.
2 years, 2 years with the plan of what we want to achieve. The first design, I think, was a bit different than what we have right now. It changed. It had a few iterations. It changed. I would say the breakthrough came with the first design of actually Andromeda, which allowed us to also move to Supernova with higher, let's say, speed, momentum, and optimism as well. Because previously, with the previous design, there were a lot of things that still had to be validated. We envisioned that it could work with the previous design, but there were a lot of things that could have gone wrong. But with the new design, with Andromeda and then the refined Supernova, we actually could see it like it had no blockers for us to make it happen. And that's when we moved full speed ahead with this design choice. We had Andromeda, which I think it was released this year. I don't remember exactly which month, but probably May. If
I can tell you.
Yeah, go ahead. So we finally released Andromeda, which brought the instant finality. No longer we needed blocks confirmation for the blocks to become final. This is what instant finality meant. We also had the decrease of the transaction finality. We halved it. The time it got 2 times faster. But the big like what users will see and what applications will see and what will completely change and redefine the user experience will be Supernova, because this brings an additional 10 times increase, so together to 20 times increase in not all the metrics, but the metrics that are currently the most important ones, which is speed. So yeah, we started working like we had been working in the background for Supernova also while we had Andromeda being developed, but of course with a lower prio there. But after Andromeda got fully tested, fixed, and launched, we sort of moved all our focus to Supernova. In the meantime, we had also some other changes, like there was Barnard, which came. There were some patches as well, and also the first iteration of the staking V5. So yeah, we had also some other stuff to focus on. But finally, yeah, I'm super happy that we can see Supernova in a state where it's very, very close to completion. And I'm saying very close and not yet done because we still need to validate some stuff. As Lucian and the other guys mentioned, we are in front of a demo which might break. Of course, it's. I hope it won't. From the things that we have covered mostly everything in Supernova. So development-wise, it's done. Now we're just fixing whatever we find in testing, and yeah, there are some edge cases which we found and are being solved. But otherwise, Supernova is performing as it was designed to perform. Of course, since I mentioned performing, we're also in the process of checking the performance indicators. So here, some already we have some improvements in mind. But as from the part of how blocks are being produced, how the execution is being done, this part is already working as intended. Now, if I am to go into detail, I'm not sure if you're here to hear me ranting about the technical stuff, or should I go more in depth, or it's good? Or
I personally love details.
I mean, I'll also see if the chat has any questions here, but personally, I'd be super interested in, like, if you take us to the engine room and like you have, of course, like this goal is like, oh, we just want to get this done, like when whatever the end time is. But there's stuff that, you know, keeps coming up. Like what are sort of what makes it so difficult to you know, even get to where you want to go in this code? What breaks, and how do you then fix it? Like, give us a little bit of an insight on how the team is actually working on this, and what the hurdles are to actually then get to this big breakthrough that is the network actually being live and working, or having a first working version, etc. Like, what is that like?
Yeah. So if I am to break it into like phases in what we went through to have Supernova ready, so it started with the design. First, we had the design validated, like with the entire core team and the other people. Also, we had some checks with what others are doing in the space and how we would perform like in comparison with them. And mostly, so you always compare with what the others are doing, because we also want to have an edge on how the network is performing, and from our measurements when we started with the design, like it was the thing that would front run everyone else. Of course, always we are a bit I wouldn't say not optimistic, but we're trying to be reserved on what we can achieve, because we first need to see a version in production and then move further with all the numbers and optimize even further. But if we have the validation that the design works, that because it has changed a whole lot, it has changed. So we need a validation. We're also doing this in internal testnets, but it's a different thing when doing it at scale, on the mainnet scale. But going back to how we did this, so it was first the design with the review from specific people here. Then we started also working to validate some parts of it, the parts where we weren't 100% confident that things will work as we expected. So we had measurements, for example, for latency on the mainnet in order to ensure that we can finish in 600 milliseconds the blocks and to have the execution going on and not lose throughput, but rather increase the throughput. So we had all sorts of measurements done to validate some of our premises, and then we started like splitting up what needs to be done into tasks that have been done in parallel by colleagues. Of course, they have been scheduled so that we don't touch the same code and we don't add more friction than needed. But I would say the development went pretty well. The major point where we always have a lot of effort was when we get close to the finish line and we integrate the things that have been developed, like everything was tested before but not integrated with all the other components. And this is when you find like small stuffs that sometimes break things, some edge cases that you didn't cover well, or you didn't think of them when this was designed. And this is the moment it needs to work flawlessly, and anything outside of the specs or expectations, you can find it at this point, because we already have a lot of tests validating the previous workings of the network. Now it's just doing the same thing but 10 times faster. So it's just running through all the validations that we have already prepared, and where we find some inconsistencies and where the inconsistencies are being detected, then digging more into it and finding the root cause of that inconsistency, and then fixing it. Some of these issues are blockers, so we cannot move with the other flows, like testing flows, without fixing the main blockers. But otherwise, once we have a running, let's say the happy path, then we move with higher speed because we can do the flows in parallel. And this is actually the stage we are at. We have the common flows working, and now we're testing we're stress testing it and finding different edge cases.
I think, speaking of testing things, the people are clamoring for the demo, so let's give the people what they want. Lucian, let's see if your mic is working. Unmute yourself and then take us through the demo and let us see what we have.
Cool. I'll just stop the camera, just making sure that the audio works, right? So 1 2 1 2. Mic check. Worked. Good. Now you cannot see if I'm through or not, or it's just my agent. But no, let me. So the audio is still here, right? You can hear me.
Yes. Yeah.
Loud and clear.
Cool. So let's see. So let's see if it works. There you go. Let me see if let me try to make it. So I think we're live, guys. So maybe just to, let's see, does it work? Can you see my screen? Can you?
Yes, sir.
Can you hear me?
We see a lot
Awesome.
of numbers and a lot of movement.
Woo-hoo!
This actually means.
That's something. That's something.
Yeah, so maybe just explaining a bit. So first, we're live with an internal run of the Supernova, very early screening, so to say. I would say premiere screening, how you see in movies. In short, actually, what we wanted today is there are 2 points. I've been looking and having internally the discussions with Adi, and I was listening a bit of the and the breakthroughs, that how the node implementation looks like. And while listening, I figured out one important thing, such that actually, if validators would, if anything would have happened to their nodes, they would have understand what's happening inside their nodes. They would have known and thought to reason about anything of what's happening inside. But now, actually, with the new implementation, I think everything changes. And in order to do that, in order to make a bit visible for everybody what's happening under the hood, we decided actually to implement a telemetry dashboard that's actually splitting and focusing on the progress of what we're doing today. So in short, just to give a sense, if until now we've been discussing about 600 milliseconds. So from 6 seconds to 600 milliseconds is alone a crazy number that I would have not imagined actually have seeing this into a visualized form or in the implementation in anytime soon. Now we're talking actually, just to give you a sense, to the preliminary finality, time to finality for block production pipeline around 90 seconds, right? So
Milliseconds, please.
milliseconds. Thank you very much. Milliseconds, 60 milliseconds, right? So we have here just we tried actually to make it as visible as possible. So in short, maybe just to recap, right? So there are 2 stages. The way I would want to explain, or we would unveil the Supernova and go through it. Also, from inside out is basically we have the block production pipeline, and then there's the execution schedule, which actually goes and add a lot more complexity to that. So, but today we're focusing on the first part, which is actually the time needed for consensus to reach finality and produce a block. A full implementation, what until now was many steps of communication. Today, I think we're proud to say just with the breakthroughs, and especially Adrian has been pushing for years almost. I think it's crazy to say that we have an average internal production or time to finality for internal finality for the production pipeline of an average of 86 milliseconds, 88 milliseconds, and like that. Pausing here, and maybe just giving the mic to the guys as well, and then we'll continue to explain.
Yeah, give us some context. What are we looking at here, Adrian?
Okay, so I think this was the contribution of Lucian, this telemetry dashboard. So here, what you can see are the stages of reaching consensus. So on the top, the block production pipeline relates to how blocks are being produced and the consensus being passed. The first 2 steps there, which you can see with the sorry, I don't see it too well here. It's the proposed block and the proof received. Basically, when you as a node in the network receive the proof, it means that the block is already final. The proof like seals the block with the proof itself, which means that there are 2/3 plus 1 who have given their vote, and that vote has been aggregated into a construct which is called the proof, and that proof serves as sufficient reason to accept a block. So this actually means that the consensus is done at that stage or at that time, specific time frame. Consensus has been reached among the nodes inside the shard, and then in parallel with this consensus, so actually after the proposed block is being validated, because after it's being validated, you still have some communication for reaching consensus, but here all the period is being is seen in those 2 steps. In parallel, the execution also starts. So what you see below is the execution pipeline, and these blocks are being also executed in parallel with reaching consensus of a block that has already been validated locally. So this is how we save the time. And what you see, the long green line. Actually, I will let Lucian talk about that one.
No. So very cool stuff actually, and maybe I was again going a bit to the reasoning of the dashboard. I was looking a bit of the implementation and trying to translate it to and trying to visualize a bit or express the excitement that I'm understanding when looking at those numbers. And then I thought, okay, so on the one hand, how do we give a tool to all the validators that will give them on the inside of what's their node is performing and how fast and amazing. But on the other hand, then the question was, so what's the one thing that, and I need to quote Benny, that would give an insight of what the future version of the protocol would look like and the performance. And now, actually, if we look particularly at the screen here, there's basically the big round is 600 milliseconds, but then you see here 200 and 400 milliseconds bar. Now, if you look here, there pretty much it tells you, assuming, okay, so if this is what my node is seeing and performing, and this is actually the green bar here on the left, it tells me that we are below 200 milliseconds, so even most of the times below 100 milliseconds time to finality. That tells us actually where are we in terms of the future upgrades of the protocol. What's happening actually, even though we re-implemented everything, how much buffer do we have for pushing the further upgrades from the 600 milliseconds to 400 and maybe 200. This, of course, is put it and say, okay, this is very preliminary stuff. It's even though I'm extremely excited about, we'll still have to see this in the upcoming weeks, actually, or days, more even broader networks or broader setups with a lot more chaos in terms of latency and so forth. But however, and just pointing a bit to one more obvious thing that, or at least obvious for us internally, is that I think one thing that I'm extremely excited about with this one is that for the first time, I think one other invention or one other investment that we made into the architecture, which is the network sharding, which we did or implemented way back when I think it was needed, but not that much, would have not been that obvious. Today, a lot of the latency, which translates into the distance, the communication distance between the validator nodes, in order to reach this kind of super crazy speed to finality, will have also actually a benefit because of that technology. So it's I think crazy to see this kind of block producing times and block to finality below 100 milliseconds, and even crazier to think that everything is parallelized with sharding and plus network sharding. Now, this is I think something that has not been executed anywhere else until now. And maybe to close and give the mic again further on, I invite everyone to maybe not everyone at once, but just to say, telemetry.multiversx.com is available. Is publicly available and should connect to the same entry points to the network to actually get a glimpse yourself how the pausing again and giving the mic.
Yeah, maybe Benjamin, just a quick perspective. I mean, we're already seeing this stuff, which is like, we were talking from 6 seconds to 600 milliseconds, right? So that's a 10x improvement. Now we're seeing here kind of on average something around like 100 milliseconds. I've seen some 30 millisecond things. Like, let's say, how proud are you of the team, or like how interesting is it to now see this live and like have this all kind of put into context and show the actual capabilities of this network, perhaps for like the first time in a real sense here.
So the internet is so horrible that I basically try to deduce 80% of what you're saying. I will deduce or assume that the question is for me and try to answer with something that I've been actually thinking a lot about. And first of all, I will just say, let's step back. This is insane. The fact that we're looking at this and that it works, and it will break in a few ways as you try to go and visit the telemetry and so on. But this is extraordinary because for the first time, people get to experience some of the things that we've been working now for years. And then especially this year, I think the conversations, the progress bar, everything that we've been discussing, once you look at this blazing speed, That's all you need. That gives you an idea of just 1,000 things that need to happen. But then what's interesting for people is maybe to think you get a transaction. This travels around the world. It communicates with other computers from around the world, and it still feels magical. Many steps that it needs to do, and then it still feels instant. I think this is extraordinary, and I want to congratulate the entire team just for the insane effort, because we're let's say hit from all possible places as we move toward this goal, but the team has not stopped, and they've delivered not only the breakthrough, but then have honed it over and over and over until it finally works. And you can see some records here. Now, to also see it beautifully displayed, I think sometimes this is everything that maybe is conveyed to the outside, and people judge everything based on that. So extraordinary efforts. Big congrats to Adi and the entire team for actually pushing forward on this. And it's a really unique and great moment for the community, whether it's builders, users, or just people from all over the world, to see this live, to maybe prepare to play a bit with it, and to think for a second on. This is the experience we'll see in all the different products that we interact. Whether it's just a transaction, buying, selling something, whether it's a transaction for taking a loan, whether it's a kind of interaction with any of the applications that we have on top. This user experience simply changes things, because it makes you wonder what else can be done. And I've written about this being a kind of technological wonder, that once something works like this, you start wondering what else is possible. Can I use this here or there? Can I use it in other settings? So just restating the big thing, that to push and reach this point, an extraordinary milestone, sharing it with all of you, community and builders and investors and so on, especially during these times, especially sort of before Christmas, is a unique moment. I was telling the guys that I just expect this type of demos to break in every possible way. There's almost an unwritten rule about that you'll get the blue screen in some way that you'd never expected, whether it's the internet cutting you off or everything. But really awesome to see the milestone and be able to share it a bit with everyone and let it sink in.
Agree. Great stuff. Maybe Lucian, you want to show us the rest of the dashboard, just so people who visit the site, again, it's telemetry.multiversx.com, actually kind of can see what they can do with it, and sort of what it means if we scroll down a little bit.
Definitely. I feel like the voice that is inside the blockchain that speaks to everybody. Supernovas, you can call me, but no, yeah, sure, definitely. Now, if we go down and scroll a bit down, so I think the idea is again going back to this analogy, two threads that in a parallel way execute now or happen and they coexist inside the blockchain. One is the production or the consensus, and then there's the execution engine that the execution actually spins off. And the way I would look at it, maybe try to turn also. The way I would look at it is basically, on the one hand, is you have one super fast train that is just shipping or running with 600 milliseconds every 600 milliseconds leaving the station, and then on the other hand, every 600 milliseconds there is a new check or an attempt for the train to be loaded, right, to where you actually produce the data, produce the materials needed, and then basically you just ship and hook them to the next train or to the next not the train, but also actually the parts that are carrying actually the load. And now actually underneath actually there's a bit of inside metrics from the validator themselves, just bare minimum CPU load, nothing actually to look at, pretty much. So lightweight that even if we're used in other environments or other implementation, that those kind of transport or message transports are protocols are super heavy. Actually, in this case, we're on an average below half of a megabit actually per second. So that's literally just a bunch of kilobytes actually just running around. Now, if we go further on, I think what we also have today, let me see if you can also see this one.
Yeah, works.
Yeah, cool. So basically we just have a Supernova demo explorer live, actually, where you can, there's a lot of stuff actually very raw here, but the most important part actually, if my internet doesn't disconnect me, you could see or should be able. Let me just stop my camera as the pockets are even delaying the refresh on the Explorer. So, but in practice, actually, what we wanted to show again and showcase today is the first implementation. The first step of the implementation is live, or at least very advanced in terms of being ready to be shipped for the next step, which is Battle of Nodes. And I think as part of that, we're actually very much heating up the load internally and pushing the limits now with the execution engine, which will actually see and make a lot of those super efficient algorithms implemented, actually a bit sweating and loading up actually those machines too with a lot of throughput in the upcoming versions. So this is I think a bit of the demo. If the guys, maybe Mihai, Adi wants, or Benny, if you want to add anything, please feel free.
That maybe I'll throw to Adi and Mihai, because their connection is much better. We saw like the CPU load and all of this stuff in this dashboard as well. I know like right now to reach these kinds of speeds that we're seeing here, other networks require insane hardware for this to even be able to run. How is this update and this upgrade going to change Validator specs? Can we still run things on fridges, or is the load getting too heavy for this? Like how much of a requirement, how are they going to change the Validator requirements?
Yeah, so definitely the recommendation is not to run it on the fridge, even though you can. As Lucian showed the
fridge at least.
or buy a very advanced one.
Fridge.
Yeah, as Lucian showed the dashboard, there's a readiness for 200 milliseconds there. And probably if you're running on a fridge and you have limited bandwidth, you won't be ready. But yeah, for this specific upgrade, also internally, we are running with the same specs as we have for the mainnet, so the minimum specs actually, and currently is being tested in this way. We are not expecting to need a change of hardware unless you're below the required minimum. Then yeah, I cannot vouch for that because we did not test with lower specs. So yeah, at least you need to have the minimum specs that were already presented before a long time ago. I think the last change we had I actually don't remember when we had the last change in the minimum specs, but yeah, it's the same. What is on the docs.multiversex.com? It should be the same. What you saw there is also very raw in the dashboard, because as I mentioned, we haven't started really deeply in optimizing things. So currently it's like this without it being very optimized. From the performance point of view, we know that we have some things that we can improve, for example, on the bandwidth. But things are progressing there as well. We have a when you're producing 10 times more blocks per the same time slot, then you basically expect to have a higher bandwidth requirement, but nothing that goes above what the minimum specs have been since a long time ago. So nothing to expect there to change if you respect the minimum specs.
And that's pretty remarkable, isn't it? I mean, just pointing out the obvious here. This is something that is, other networks don't reach anything close to this speed, with much higher requirements. You will be able to really still have a fully decentralized network where you can run a node for, I think, what is it, $50 or less, and participate in validating this network at light speeds here.
One good fridge is a great contribution to the network, and it will keep your food and keep your network. So that's a simple way of putting it, actually.
Yeah. So maybe everybody can look at this dashboard at home, and I think we've shown the Explorer as well. Maybe we'll share the address for that as well, if you want to check out that it's live. Also, I will point out that during the stream we changed epochs, so that's always I know Adrian was scared of that one, but it did work. Nothing broke, and we changed from epoch 4 to 5 here. And maybe we'll see another one before the stream is over. But let's talk a little bit about the implications of this network. Like you already mentioned a few things, Benjamin, with like agentic use cases for this, and other things that we can now really see coming on a chain that's as performant as essentially like a Web 2 experience is. Talk a little bit about the implications of Supernova coming to mainnet, and what you foresee or hope to see built on MVX with Supernova.
Sure. So a few really important things to restate. To see this live, to see it play the music it plays, to let the blocks fly like that. That's the best situation we can be in. Now, the question is, as we've built this highway with many lanes, where you can really drive without speed, what are some of the interesting things that you can finally plug and they feel magical? And with Supernova, it really feels like we're at the frontier. We are sort of in the future, and now whatever use case we put there, it should make you want, because it almost feels too good, right? In terms of the speed, especially when you consider that it's not only work that's being done on your computer, but it's work that's being done on your computer, and then it conveys this message and information around the world, and it needs to reach consensus with other computers so that it moves forward. Question is, what are maybe two directions to just think about and process a bit and look at that lend themselves extremely well to this type of network? Well, one of them is the obvious and maybe most important use case that we've seen within the blockchain space, and that is just blockchain eating finance. And for the first time, if we look at of architecture, you can think about any interaction that is financial, and you can imagine how it can be better. So let me take a few of the examples. Suppose you want to just send some transactions, send some money, change that, send it to your nephew or your cousin somewhere else in the world. Well, you're on the phone, you're opening the wallet, you make a transaction, and boom, it's just done. You don't need to wait. There's no minutes where you need to wait and you don't know if it works and so on. It just works. Suppose you move one step further. You want to take a loan. You want to buy something or sell something because there's an opportunity to see it right there. Again, you just press the button, and this time it simply works. That's it's almost shocking because I cannot tell you an hour of things of actually how the experience feels and so on. Then you move forward. Suppose you're on this exchange, you want to do even more high leverage things. Literally, you're on the exchange, you want to bet on something, you see this great opportunity. Again, you can buy, sell, really move extremely fast, because now you have not only the bandwidth, you can not only scale, but it can move extremely fast. Now, the financial aspect, whenever you think about anything that has to do with finance, is very interesting because everything that we're discussing about AI, for instance, if I were to change the perspective for a few seconds, is just amplifying what I said. So what will AI, what will agents actually need in order to be productive, in order to add value, in order to become part of our lives? Well, they'll need wallets, they'll need to be making transactions that are very inexpensive, and transactions that can move at scale, both with speed and in amounts that are unprecedented. That's actually the perfect type of use case that stress tests the network at a scale that we could not see with humans. So what will agents typically do? Again, just to make it very concrete, agents will make transactions. They'll need to rebalance some of the accounts and change things and so on. What else? Well, they'll take loans, they'll make trades, they'll sell things, they'll buy things. There are these agents that are called bots. They can do things, and now they can do it with much greater speed and at a much greater scale. What else? Well, there's also the type of interactions that are much more complex. Someone gives them kind of objective, they go, they search stuff, they can do maybe commerce, and they can do this for us in a way where tens and then hundreds and then thousands and then millions of these agents can perform this type of actions simultaneously, up until the point where you actually basically can use any other network. You won't hit any bottleneck, right? You won't see the magic. It's precisely when everything else cannot handle the load anymore, and when things don't move as fast, when you start thinking, is there a better way maybe? And so, to conclude, I believe finance is the first pillar that will be massive, just because it reinvents some of the experiences that we had, and it makes them 10 times better. You don't need to wait. You can just do things. And then if you take every applications that we have on the network, that's one way of looking at it. How would I feel if I go and buy something, sell something, take a loan, interact with it, whether it's through cards, whether it's through some other more complex interactions? Well, it does feel magical. Then can I have this type of almost bots that are more complex, that can do more for me? Can I maybe have a bot in the future that I can rent or buy, almost as I buy a car and put it on a self-driving Uber? 100%. I think most people will want to have this type of bots, this what else substrate will they be on than a substrate which enables deterministic commands, which enables you to issue these ideas, these objectives, and then the bots can pursue them. Will this require many iterations? I'm sure. Will the speed of AI help us reimagine some of the applications that we have, that we're playing with? I in the ecosystem, I think most builders are amazed if you're discussing with them by what AI can do today, what it can do today versus 1 year ago, versus 6 months ago. And so Supernova is this massive experience improvement for both humans, everyone that's using this, that has been building on this and so on, but then also machines. And very, very excited when this type of thing in action, and when I see some of the builders behind the scenes already optimizing for these use cases that they want to deploy at scale and play with. So this, of course, are just a few glimpses, but I think they capture the essence of what it actually means to rebuild everything from scratch for this type of massive improvement, and why we are again at the frontier, and why we're super excited about this milestone that we can finally share with the community.
You muted yourself in the end there, but I'll take the opportunity because you mentioned builders. We do have a hackathon that started on Tuesday, I believe, that's going on until the new year, to specifically build with this amazing new technology, take advantage of these things. There are great ways of now integrating bots and AI and other things into all kinds of things. There's a DeFi track, there's an infrastructure track, and there's a gaming track. So everything that really kind of benefits from hyper speeds like this, that is scalable, that runs on low spec machines even, is now, you can start preparing for it, build for it. There's $60,000 in prizes for the hackathon. So if you have some time over Christmas, feel free to do that. I'll put the link here if you want to register or learn more about it. And maybe we'll conclude a little bit after having these thoughts. Maybe just one more added, maybe from the technical team. Like, what are you guys most excited about in terms of like what this now enables for builders, or internally, the use cases, and then we'll start wrapping it up and let the people try the board themselves.
I think I'll start this time.
Yeah, go ahead.
So we've talked about speed in all kind of ways, and I believe that speed is tied to user outcomes and engineering trade-offs. Just because Adi already said that this is very nice in a demo, but we have to think about how fast can we go while preserving some security assumptions and some decentralization goals. Because I believe what matters most is performance under stress. So we will have to see how it performs under load spikes, some adversarial conditions, some node diversity, and so on. For the end user, they just feel latency. And by feeling it so fast, I mean, you have seen it's on average around 100 or 90 milliseconds. It enables, I would call them real-time experiences. And real-time experiences, it means that you can think on a different way about trading, about games in general. Payments, yeah, it's of course it's the most important activation mode, but then also decentralized on-chain coordination. And this is very important, especially in sci-fi. And this is something that I already explored with Lucas and some teams that are building in the sci-fi area, and for bringing and decentralizing calculation opportunities.
Sci-fi, as in rockets to move to Mars, or sci-fi, a different type of sci-fi.
I think decentralized science, right?
Sorry.
Are you talking about the
Or a friend.
decentralized science stuff?
Yeah, decentralized science. Yeah,
Yeah, exactly.
science, financial science. Yeah.
So
Yeah, so this is
DeSci,
this. Yeah,
because
yeah,
definitely not sci-fi yet.
yeah.
With Supernova, you
This
could
side.
say sci-fi. DeSci becomes sci-fi. We can use that. That's a good
Yeah.
idea.
Yeah.
I wanted to help you a bit.
Yeah, and those are some very important enablers that will bring a lot of many new opportunities. And I'm very curious about BuildWars, because the very next step after finishing the BuildWars hackathon will be moving those applications to the Battle of Nodes testnet and see how they behave.
Yeah, and since you mentioned that, so let's just quickly, and then we'll wrap it up. What's the roadmap for what we're seeing now, the magic on screen to actually hit the homes of the people? Where we have this first great pulse check. Now what's next?
The team will continue to build and test and stabilize and reach a final branch that can be audited, because that's also in the works. And meanwhile, we will start preparing the Battle of Nodes campaign immediately or soon after the finishing of the hackathon. So around the second part of January, I would say. About Battle of Nodes, it was already described, so I will not go into details. We have the guild wars, we have a few tracks about bug bounties, validator tracks, infrastructure provider tracks, and so on. And soon afterwards, we will, in January also, we will start the governance call in the first part of January. Most probably on the 5th of January, we will announce the governance call. And afterwards, we will follow the natural process by upgrading the testnet, the public testnet, and running some tests there. After everything looks fine, we will continue with upgrading the devnet. That's probably where most of the builders in the community and in the ecosystem are going to test their apps and dApps. Also, they are probably going to do it on the Battle of Nodes network as well. But there we are thinking about some different scenarios that we would like to test. And afterwards, if everything looks fine on the testnet and devnet, we will follow with the normal process for upgrading the mainnet. And then obviously we will have some few chances to simulate this upgrade on the Battle of Nodes network as well.
Yeah, as you said it sounded like a long time away, but it's not that long.
Yes,
Actually,
2028. We're only planning this for 2028.
yeah. So some
please.
of the things will are happening in parallel, like the governance, which will start early next year. Hopefully, the Battle of Nodes will show that we don't have any issues, because we're also planning some stress testing there. But yeah, with the public testnet and devnet, those are somewhat required by us for the stability of the mainnet, required steps. But yeah, I think we are seeing the mainnet becoming sort of ready for upgrade during, or we'll see the results of the Battle of Nodes, but during January, I would say.
Mm-hmm.
Can we add a percentage point today, Benjamin?
I think we can work on that. We'll work on that until the morning, and tomorrow maybe we get to that. But I just want to restate this. A really big step for the network, for the team pushing this out, reaching this and showing something really beautiful. And I cannot stress enough how much effort has gone into making it work. And then even usually how these demos happen. Like 10 minutes, there's still an upgrade that needs to happen. There's some new things there, and so on. Because we're giving you a sneak peek of the latest release with the pulse check. You almost see the heart of Supernova with this telemetry that beats and outbeats with the speed that should make you wonder what would you actually build there. What's the thing that maybe we don't need 100 use cases? One use case that really works can immediately change the perspective of people and can draw the attention on what feels like magical and what will make the blockchain disappear. So that type of technology I want more of, and it is a massive step. Happy that it worked, and I'm actually surprised that it did not break in some interesting and funny way. Although we could say the internet was quite broken, but yeah, the pulse check actually worked quite well.
Yeah, the blockchain was never broken, just the connections here. Yeah, Lucian, last thoughts, and then we'll wrap it up.
Sure. Maybe if you can just share my screen, I would love to just bring something up and keep 5 seconds of silence such that everybody thinks about what we have here. I'm just joking, but actually, and by the way, just going back to Benjamin's what he said, I hope blockchains would not disappear in anytime soon. We have put a lot of effort, and especially the team put a lot of effort. But nevertheless, I think the latest block finality was 43 seconds, and I want to just I don't think there's much more to say beyond that. Milliseconds. Again, I'm
not ETH.
Yeah. So yeah. That being said, actually, I just wanna say really good progress today. A lot of effort still to go. Even more pressure now. Actually, showing this kind of numbers to see how it will translate. So again, this is very much a conservative approach, or I would say the production is a lot tougher when it comes to latency and many other metrics or relevant key components actually that brings us to those kind of numbers to production. As the internet actually evolves and hopefully the topology of the network improves and the toasters within the network will also improve, and we will be able come at least close to what we saw today. Again, thanks a lot. Maybe just also from my side, sorry for the internet, but you're welcome for Supernova. Pausing here.
Yeah, thanks guys. Thank you so much for braving the internet. Thank you out there for being with us through the little hiccups here in the beginning and throughout. But you can go, I'll one last time put the website here. Go to telemetry.multiversex.com. Check it out for yourself. We'll also give you the link to the server. I think it's like demo. I'll post it. We'll post it in a bit and add that there. And yeah, thank you for being here. The use cases are really what I think makes this so exciting. It's a huge step. The network has a pulse. We're just working on getting it to actual production. And Mihai already outlined the steps there. They're very concrete. It's actually not very long from here to there. It's a final sprint that will take us to this upgrade, and that should be very exciting. In the meantime, feel free to build some stuff in the build wars and play with the network and explore the actual opportunities, because there are many. Thank you so much for tuning in. Thanks guys for joining for the stream. Thanks for all the efforts, and we'll see everybody soon, I'm sure.
Thanks.
See you on the other side, guys. Thank you.
Thanks, guys.
Thank you.
Bye.
Bye.